My name is Don Coleman. I work for Chariot Solutions, and today I'm going to talk to you guys about the physical web. So the physical web is this concept that promises seamless interaction between devices in the physical world and devices in your phone. Objects and places are going to use beacons to broadcast a URL. Your phone can discover these pages for things, and you can choose to connect to the most useful pages. So we're going to talk about some of the concepts behind this, hopefully have some demos that if all goes well they work, and then how you can put this into some of your projects and devices. So Scott Jensen, who works for Google, he's the guy that came up with the physical web and the concepts behind this. And his idea was you should be able to walk up and use anything. You shouldn't have to go and type a bunch of URLs into your browser and make things happen. Or he just wanted to remove a lot of the friction between interacting with devices. You have the internet in your pocket, so it should be really easy to connect to things. Part of the concept behind this is every device can have a URL, or every place can have a URL, or places that you want. The other thing is the physical web is open. You don't need permission to implement it. You don't need permission to use it. The specs are on, if you go to physicalweb.org, I think it redirects to Google's GitHub page, and all the stuff is out there. There's a pretty active community around it. So Scott had one example which I thought demonstrated the physical web very well. So there's a short YouTube video, but I took some screenshots because I can control the pace a little better there. So the idea was, you get out of your car, there's a parking meter there, and you want to pay for parking. So you can take your phone out, and you can go to the, I think they call it the Today view in iOS, or you can get a notifications in Android, and you'll see that parking meter should show up and say, hey, I'm parking meter, whatever number that is. And so you click on that notification, and it opens a web page, and then from that web page, it'll load an app that starts to interact with that parking meter. There's no direct connection to this parking meter. It's going up, it's hitting the web page, and then the server and goes down and talks to the parking meter. But you can add some time, and as you're adding time, it's syncing to the meter. And then at the end, you can say pay. It'll happen with Google Payments or Apple Pay or something like that. And it'll tell the parking meter that, hey, this person's paid, it's ready to go, syncs the time. My phone could also remember which meter I was at. I can know how much time was there. So that's a nice example. There's a lot of moving parts, but it works pretty well. So one of the questions is, well, couldn't you just use an app for that? And yeah, you could. In fact, there's plenty of places, Philadelphia being one of them, that you can use an app to pay for parking. I was on vacation in Florida over Christmas, and we're down near the beach, and you had to put an app on your phone. My wife is trying to download the app. It took a long time to get the app on there. Eventually we paid, and it worked okay. So apps are great for a lot of things. I have Sonos at home. I like to play music on that. There's a Sonos app that works really well. Things that I'm interacting with all the time, apps are great. Things that have one-time or infrequent interactions could be a good use case for the physical web. As microprocessors get cheaper and cheaper, there's Wi-Fi and cellular connectivity everywhere, there can be many, many more of these devices. I already have too many apps on my phone. I don't want to put an app on for everything. So there's some cases where the physical web could be a really good solution. The other thing is, hey, isn't this just a fancy QR code? And so the answer is yes and no. QR codes used to be everywhere. They didn't really get adoption. They're kind of clunky. You got to find a QR code scanner on your phone. You got to get it to be in focus. You got to make everything happen. I personally, if I'm somewhere there's a QR code, I'll feel like a dork if I'm standing there trying to get the thing into focus. The other thing with the QR code is you have no idea what you're scanning. Sometimes there's a URL written below it, maybe not. So QR codes work. They just didn't gain a lot of adoption. Physical web can kind of replace that. It's a way to get a URL from a physical thing to your phone. The other nice thing about physical web URLs is that you can sit back and you can passively, by scanning, find what's around you from a short distance away. One of the things about the physical web is it requires user interaction. These aren't push notifications. You think of how annoying that would be if you're walking into a store or walking down the street and you start to get all these push notifications for all the devices around you, your phone's buzzing. As a user, I don't want to be bothered by lots of random devices and things. So the way it works is when you go to the, on iOS, you swipe right and you can start to scan for notifications there. On Android, you pull down. And so they're passive notifications. I have to, want to be looking for the notifications and then I have to click on them. So don't bug the user is one of the theories behind this. So how does this all work? Beacons are the thing that's behind the physical web, and it really helps make it work. You may have heard of beacons from iBeacons. We're not using iBeacons for this. We're using something called Eddystone Beacon. I'll talk about that more in a minute. But the idea behind a beacon is it's kind of like a bellbuoy or a lighthouse. It's just sitting there sending information out. If you're close to a buoy, you can hear it dinging in the waves. If you're near a lighthouse, you can see it. You have to be kind of within the proximity of it. When you're hearing the things, you don't always know how close you are to it, but you know you're close. So for things like iBeacons that are just broadcasting numbers, you have to have some sort of chart or some way to tell you this beacon is located here, this beacon is doing this, and then you can kind of navigate where you are for indoor space. We're not as concerned about absolute location of a user when we're doing the physical web. Since we're trying to send out a URL as part of our beacon payload, we just want to know that the user's close enough so that this device may be interesting to them. So we do this with Bluetooth, specifically Bluetooth Low Energy. And one of the reasons we use Bluetooth are all phones have Bluetooth Low Energy now. It's been a few years ago, I think the iPhone 4S is when it started coming out. Android, for a couple years, all the Android devices have good Bluetooth Low Energy support now. Bluetooth Low Energy has advertising packets. A Bluetooth Low Energy device, a beacon, or some other hardware that you're connecting to, it advertises itself. It sends these packets out that says, this is what I am, these are the services I offer, you can connect to me, you can't connect to me. So with a beacon, we're just reusing that advertising mechanism to put the data that we want into the beacon. The beacon can broadcast the data, and then any observers like a phone can receive that data. And it's a great method for connectionless data transfer. With a lot of like a Bluetooth device, if you're going to connect and interact with it, usually you scan, you find something, you connect to it and start to interact with it. With the beacon just sends the data out and you can choose whether or not you're going to do anything based on that data, but you never actually need to connect to the beacon. So Eddystone Beacons are what we're going to use. You can kind of think of Eddystone as like Google's version of iBeacon. One of the nice things about it is the specification is open. iBeacons are pretty simple and people reverse engineered how they work, but technically it's a closed spec. Technically you need to, before you can put that iBeacon stamp on your product, you got to pay licensing fees, all that stuff. So what we're doing with Eddystone is we're broadcasting a URL in the advertising packet. And one of the things to know is that advertising space is very limited. There's 31 bytes in the advertising packet. And Eddystone needs to do other things like tell what service it is, what type of beacon. So when you take all that metadata out, you only have 17 bytes to put a URL in, which isn't very much, but it's enough to make things happen. So Eddystone has a simple encoding scheme for encoding URLs that take common pieces and substitute them with 1 byte replacements. But even with those schemes, you'll sometimes have to use URL shorteners to get your URLs into a beacon. Something like chariotsolutions.com is too long. By the time you encode that, it's still 18 bytes, so you need to use a URL shortener. One thing to note is that Bluetooth 5 came out earlier this year. Bluetooth 5 increases the advertising space to about 256 bytes. So theoretically, we should be able to broadcast longer URLs without shortening them or any obfuscation going forward. So a beacon is just a small Bluetooth device. Usually they're round for some reason, have a battery in them. So if we imagine we had a beacon like this, And it's just going to start advertising or shouting out, hey, here's the URL that I'm offering. If you have some phones around, the phone could be listening. You need to have a beacon scanner on your phone in order to see these beacons. So if you have a beacon scanner, you could see that the URL is there and you may actually get to use it. If you don't have a scanner, you have Bluetooth turned off, stuff like that, you just won't get that notification. So Android has something called Nearby in the latest versions of Android that have beacon scanning built in. I talked about before that you wouldn't have a notification. The first time you come near a beacon, you may actually get a vibrating notification that says, hey, we found a beacon near here. Do you want to see it? Do you want to opt in to scanning beacons? And then if you say that, then the beacon scanner runs in the background. If it doesn't, if you say no, then it won't run. So the other thing we need is we need some physical hardware to make these beacons happen. So the one on the left there is a Radius Networks X4 beacon. It's big, it's waterproof, it's weatherproof. You can bolt it to the side of a building. But that's kind of the exception. So they're not usually this big. The two on the top are Eddystone Beacons. Eddystone did a lot of advertising and sending their SDKs out, so they're a pretty well-known name. The purple one is one of the newer ones, which is a little bigger than the blue one. One of the things they found with Eddystone is when they first came out, they're like, batteries are going to last 2 years. This is awesome. And in about 3 months, the batteries died. It was like, oh, crap. So they changed the advertising, and so they advertise less often. But also in the new ones, they don't physically look that much bigger, but they're a lot heavier. I think they have 2 big batteries in them. The one with the black logo on it is one that Google gave out at Google I/O a couple years ago, I guess. And then the really small one's another Radius Networks beacon. It's just a little bigger than a quarter inch. So that one's great. They got a little, not a lanyard, a little holder so you can put on your dog's collar or something if you wanted. So one thing you'll notice if you open any of these beacons up is that they're mostly batteries. So from the Radius Networks beacon, I think this one's supposed to last 5 years or something. It's all batteries and a little tiny microcontroller or Bluetooth radio and an antenna. But even if you go rip one of those Eddystone apart, same thing. It's a lot smaller of a device, but it's mostly battery. And then down to the small coin cell batteries on the Radius Networks one. So if we have a device with a bigger battery, we can run a lot stronger signal. So that means people can see it farther away. We can advertise more often, so it's easier to discover. If you're advertising every 100 milliseconds, you're going to run your battery out, but you're going to ensure that more people see it. If you're doing it every 2 seconds, you're going to get your battery to last a lot longer, but people may not see what's happening. So for development, I was using a lot of these Google beacons, because the nice thing, you can't see it in the picture, but on the side of them, they have an on-off switch. So that's great, so I'm not walking around advertising all these beacons out of my backpack as I go everywhere. So if we want to create a beacon, let's create a beacon for a physical location. Devices can have beacons, locations can have beacons. One of the examples that the physical web website has, they have a lot of good examples, so if you're really interested, check this out after. But it could be something like a bus stop that'll have contextual information. Each bus stop will have its own URL, so when you're at the bus stop, you can get that notification and you could tell, hey, what's the schedule, where can I actually go, when's the next bus coming? I don't have a bus stop with me today, so let's create a beacon for ETE. Basically, all we need is a URL and a beacon to broadcast that URL. So once again, we're going to use Eddystone Beacons, and we're going to use the URL encoding scheme to encode that. So if we start out this phillyete.com, which is a URL that we have, that's not the official PhiladelphiaEmergingTech.com, but it redirects there. It's an HTTPS URL. If you're making Eddystone Beacons, you need to use HTTPS. So even though this is a short URL, it's 21 bytes. We can use the encoding, so HTTPS:// becomes 7, and .com becomes 00. So if we encode that, we get that down to 11 bytes. So I encoded that, and I put that into a beacon, and I tried to run it, and it wasn't showing up. One of the reasons is this failed some validation. we're doing a bunch of redirects and stuff like that. And somewhere along the line, there was a HTTPS certificate for a different name or something in there. So it wasn't reliably showing up. So what I did instead is I used the long full URL, the HTTPS 2017 phillyemergingtech.com. Obviously too long even if we try to encode that. The full URL is 35 bytes. So I created a short URL using the Google URL shortener, which is ugly, but it works. And then that gets encoded so it goes down to 11 bytes. We can put that onto the beacon. So my thing that was mirroring my Android phone was not working today, so we're going to do some screenshots for a lot of the Android stuff. If you've opted into Android Nearby, you should see a notification. I have this beacon right here is advertising that URL we talked about. This is an Eddystone beacon I set up. We'll show you how you set those up later. And you can see down at the bottom here, it says Philly Emerging Tech, and it has a little bit of blurb from the website. So that's the first time I go into Nearby. Now, when I swipe down my Android phone from the top, I sometimes see a Nearby notification, and it'll say Philly Emerging Tech. And then I can click on that notification, and it'll open the web page in Chrome. So other than the initial vibration from, do you want to opt into Nearby, my phone didn't bother me. So it's kind of a barrier to adoption, but once people kind of know about this, they may know, hey, I'm in an area, let me look around and swipe and see if I see anything that's there. So we used the Google URL shortener, which was a really ugly URL, but on my phone, I saw the full URL. So how did that work? One of the pieces we need is we need the beacon scanner. With latest Android, that's built into Android. I think even some of the older ones, they've backported it into there. So there's a Google proxy that sits in the way, and when it gets that scan from the beacon, it goes and it talks to the proxy. One of the things the proxy does is translate it back into the regular URL, so that on my phone I can actually see what I'm connecting to. The other reason they do this is for privacy. They don't want beacon, they don't want me to be able to set up a beacon and then set up a website, and then anyone that has Nearby, that they come, they hit my beacon, and then they hit my web server, and I can track people coming in. So it disconnects the user from the website until they click on it. Once I click on the website, I can be tracked and all that stuff. So I can't be fingerprinted by someone running a beacon, but it does mean that all that data goes to Google. If you have an Android phone, you've probably already made that bargain anyway. So it does protect your privacy somewhat. Google still gets to see everything that you've done. When Scott Jensen was designing this, he really was concerned about privacy and making sure users weren't tracked. Some of the early betas, we were trying to fit a lot of data into the advertising packet and kept running out of space and things like that. So there's something in Bluetooth called a scan response. Bluetooth sends out a scan packet, and then the device can say, well, hey, give me a scan response packet, which is another 31 bytes of data. And so by splitting up the service definition and the URL, you could actually fit a better URL in there. So I sent Scott an email, and I'm saying, hey, you should do this, and you should make this happen. And he's like, yes, that'll technically work, but we don't want to put that in the spec, because if you do that, then someone can make a malicious beacon where it requires that back and forth, and then the beacon can now get the MAC address of the phone that connected to it. So there's definitely some thought around that, with the caveat that this is Google and they track everything. So. The other thing the proxy can do is it can filter out spam and phishing attempts. So the first person to hit a spam link, you may get that. As the first person to get a beacon with a phishing link on there, you may get that. But hopefully they're analyzing these, they're removing those links. If people mute them, if people report them, the quality of links should get better. The other thing it can do is it can rank them and order them. I think that it tries to order them by signal strength to put the strongest ones highest on the list. And then also over time, they're supposed to show you the most useful ones through some magic algorithm or something like that. So that's good and bad. Good as a user, I want my links to be ranked and curated. As a developer, it's kind of annoying because there's some magic filter that this goes into, and my links may or may not be seen. So that was for Android. We can also do this on iOS. It's not built in. The idea behind the physical web is it should be built into everything. It should be seamless and all that. If you install Chrome on your iPhone, and then you go and you swipe right and you install the Chrome widget, it will give you an opt-in to say, hey, there's some physical web beacons. Do you want to scan them? And then it works very similar. The phone doesn't actually scan for beacons until you swipe over. And once you do that, it'll start to find beacons, and you can click on them, and then it'll open in Chrome. So it works very similar to Android from that perspective. So theoretically, Apple could integrate the physical web into iOS. Probably pretty unlikely. If some of you guys tried this, it might not have worked. One, because this stuff is new, and two, because it's demos and things fail. So there's a few other ways you can get beacons. There's a physical web app. There's one available for Android and for iOS. And that goes out and does some scanning when the app is open, and it finds these beacons. It talks to the proxy and decodes them. It seems to be a little more lenient about when it will show you things. There's times when there will be a beacon there, and you can scan with like a Bluetooth tool, and you'll see the beacon, but they won't actually show up in Google Nearby or Google Chrome. But they almost always show up in physical web. Same thing here. You can click on this, and then it'll open in Chrome. So this is kind of a hack, but it's, this is early in this technology. The other thing you can do is if you have an Android device, you can enter the Chrome URL physical-web, and it should scan and list all of the physical web devices that are around you. Okay, sorry, we talked about the proxy, so skip that one. So one of the keys here is it's a proximity-based experience. We only want to see URLs for things that are around us. So when we're close to a beacon, that works well. Ideally, we can use beacons without an app, but you could also build the beacon technology into your app too. We created that link, or I created that link for the ETE schedule or the ETE homepage. You could also make it to link to the schedule. Then the server could look at the time of day and maybe link you to the right thing. I could have one beacon in here that would broadcast the ETE URL. Maybe I want to cover a big area. I mean, this isn't a huge area, but if you're at a really big conference, I could have 20 beacons advertising that one URL, and it would be okay as you move around. You could also do contextual ones. Maybe you'd have to do some testing with this, but you could have theoretically a beacon in each room that would show you a specific schedule for that room and time of day. So you can really kind of get creative on what you're doing. And if we're doing something like that, you could actually build this technology into the apps if you wanted, or you could just make them work with the web. So the key thing with that, especially with what I just did with the ETE schedule, is that was almost all the web. All the beacon did was provide a jump start, so I didn't have to type a URL in. I relied on some of the machinery in the operating system to make that happen, or an app that I had installed. And so think about contextual stuff. The bus stop that gives you the schedule, a museum that as I'm in front of a painting, it could show me a page that had more details about it. One for your dog that had his name and contact number in case he got lost and an Android person found him. All right, so let's talk about a more complex example. Like, what if we wanted to control some lights? The last example was pretty simple, but I mean, really, it was just putting a web URL in there. So, once again, as a user, I want to make it easy for me to find stuff that I'm interested in. So, this next example uses Web Bluetooth. So, Web Bluetooth is another web standard. And what the idea behind Web Bluetooth is it lets my browser go out and interact directly with a Bluetooth device. W3C is working on the standard. As far as I know, it's only implemented in Chrome right now. It works on Android, Mac, Linux, and Chrome OS. It does not work on Windows or iOS yet. So I brought a lamp over there to my presentation. And we're going to set up a beacon, which is going to broadcast a web page for that lamp. And then that web page will use Bluetooth to communicate with the light. That light over there doesn't have a network connection. All it has is a Bluetooth radio on it. So this sample is only going to work in Android for phones, but hopefully, once I have this work, people can try it out too. So the way this works is I have an Arduino 101, which is, it's an Arduino board with a built-in Nordic Semiconductor radio on there, so I can create Bluetooth services, and I can also control GPIO, or general purpose input-output. And so I have two wires that go over to the power supply, and this is a special power supply that when I put voltage through, it toggles an outlet on or off. So kind of like I'm switching an LED on or off, but I'm doing that, I control 120 volts. That's a good piece of hardware that broke yesterday, so I'm not using that. I'm using this replacement piece, which does the same thing. It's just tougher to get a picture of what it does. So once again, if we look at this, we're going to have a physical beacon. It's going to broadcast a URL. My phone's going to find it. It's going to talk to the Google proxy. It'll get the URL. Then it'll go load a web page from my server that has web Bluetooth JavaScript in there. I'll be able to make a connection with that Arduino, and I'll be able to control the light bulb. Fingers crossed. So one of the things we're going to need for that is we're going to need a beacon. I have lots of beacons here. So this is an Eddystone beacon here. It's not configured right now as a physical web URL. I'm going to try to, I'm going to exit my presentation and see if I can mirror my phone. Here we go. So I'm going to launch the Eddystone app. I'm going to hold this beacon here, and I'm going to connect to the beacon. So what I did is I cheated earlier. I set this up as a physical web beacon so the URL's in there, but then I turned it off and I set it back to be a regular beacon. So all this hardware can broadcast many different kinds of beacons, so I'm going to change it from an Eddystone beacon back to an Eddystone URL beacon. We'll give it a minute to sync here. So we can see there's ete17.com/lamp is my URL. So now we're going to have to do some screenshots for the Android stuff. So I'm going to swipe down on my phone, and if everything works, I'm actually going to see that URL there. And this is, maybe I need to disconnect. Hold on one second here. This isn't as cool because you can't see it, but it's not working, so that's okay too. So I'm going to open the physical web app, and hopefully it'll show up in there. Make sure Bluetooth is on. All right, so that's totally failing, which stinks. So I'm going to switch over and show you from, I don't want to waste a lot of time making that work. I have Chrome installed here. So hopefully we can run this same demo from Chrome, and then afterwards we can show it happening in. So with Web Bluetooth, I need a user interaction, so I had to push that. Oh, you guys can't see this. Hang on, let me try this again. There we go. So I have to hit user interaction, and it wants to pair with the lamp. So I'll choose to pair with that. And then now it's loaded this web page and it's discovered this. I'm not winning any awards for the user interface here either. But I have this power button, and as I click the power button, it controls the light. And then it disconnects it. So if you have an Android phone and that beacon decides to come back to life, I have a back. If you see the beacon, you're welcome to connect to the light and see if you can actually control it. One interesting thing about a light is it's tough if you got a bunch of people that want to control it. One of the nice things about Bluetooth is it only lets one person connect at a time. So you can scan for the device. If you see the device and you get to connect to it, you're the person controlling the device. And then as long as you disconnect when you're done, the next person can come in and connect to it. That works really, really well for some use cases. It doesn't work as well for other use cases. So here are some screenshots of this happening on Android. So we'd connect to the lamp, and it works almost exactly the same. So the important thing here is the physical web just provided the link. Everything else was done with web standards, or web soon-to-be standards. And so you can use this trick to do a lot of other things. Now I've left iOS users out in the cold. Technically, okay, good, someone else got connected to it. Technically, you could make a Wi-Fi version of this too. The problem is if I had a Wi-Fi version of this and more than 2 people tried to connect to it, you'd be fighting with each other to see who would control it. It would make my job of writing the code much harder. Here, it was very simple code. Works great for a demo. So another thing we can do with the physical web is I have a temperature sensor. You may, if you've seen any of my Bluetooth talks, I've used this exact setup before. So on the left there is a DHT22. It's a temperature and humidity sensor. You can read the temperature and humidity every 2 seconds. So it's a slow sensor, but that works good for most cases. On the right-hand side is a particle photon. Particle is a company, photon is the board. It's a Wi-Fi based board. I think they're about $19. And you program it like an Arduino. You use a web-based IDE to control it. It has 2 sets of firmware. One set of firmware connects to the internet and connects to Particle's servers, and then you run another set of firmware where you're controlling stuff. So it's connected through my MiFi box here, and it's connected to Particle's cloud. And then I have some firmware on there that's reading the temperature from there, and every 2 seconds it sends that up to the server. And then that from the server, it gives us a way to talk to it. So we're going to make another beacon that's going to broadcast the web page for that temperature sensor. We'll be able to connect to that, and then all our interaction happens with the internet. We're never going to talk directly to the sensor. And in fact, it's not just one server there. It actually goes from the Arduino or from the Particle to Particle Cloud. Then I have a process on another server that listens for those events, and then it stuffs those events in Firebase. So the phone actually talks directly to Firebase. The thing that works well about this is that multiple people can use it. It works on iOS. So once again, we'll need to set up another beacon to do this. So I'll switch back to, this is the Estymote app. So I'll switch to this other beacon here, and I'll turn on the Eddystone URL for this. So you can't really see down at the bottom. So this is broadcasting a URL for the device. So now if I swipe right, up at the top there, that's the Chrome widget, and that Chrome widget, the temperature and humidity sensor, is the top one here. So if I click on that, it goes out, it opens the web page, and then it starts to get those temperature readings. So anyone that can see that beacon should be able to do the same thing. And then since it's updating the database, if I hold my hand over here, theoretically it should start to increase. There we go. So it's getting live data from that sensor, but it's going to the server rather than going directly to the sensor. If we wanted, I could have set up a Bluetooth sensor to do the same thing, but I'm trying to kind of cover some of the bases. So this sends data from the Arduino to my phone. There's really no reason we couldn't do things like that parking meter did, where we send data from the phone and it goes back down to the Arduino or other device too. One of the other physical web examples is a reservation system for a restaurant. You can go, you get the notification that the reservations are happening. You can get in the line. It'll say, hey, you're the 4th person in line. You can opt into a Chrome notification, which would actually buzz your phone and ding you, and then you could power your phone or lock your phone, put it back in your pocket, and they notify you because they have a web worker running on a background page. And so once again, we're providing that link and then using just standard web stuff after that. Okay. So here are some screenshots in case that broke. So creating beacons. The easiest way to create beacons, if you get some hardware, you can order an Estymote SDK. Radius Networks, they sell them on their site. And there's probably, I don't know, 50 other beacon manufacturers, and they probably all work fine. Beacons are really pretty simple. Most of these will come with some sort of configuration tool. You saw we had the Estymote one on the left. On the right is the app for configuring this big beacon here. These smaller beacons that they gave out from Google actually use the physical web to control them, so it's good if you have an Android device. When you turn it on, it goes into advertising mode. It advertises a web page. You connect to the beacon, and then you put the URL in there. If you don't want to go out and get beacons, and you have an Android phone, there's a device, an app called Beacon Toy, and this lets you create Eddystone Beacons and a whole bunch of other beacons too. As long as you have new enough hardware that supports creating Bluetooth services and advertising, it should work pretty well. It's a great way to experiment there. So I use the Arduino 101 for that because it has good Bluetooth services on there. The current version of the firmware will not let me create beacons. I think the new version, which is coming out soon, will. If you're using other Arduino hardware with a Nordic Semiconductor radio, Sandeep Mistry has Arduino BLE peripheral, which is a library I use for creating a lot of Bluetooth services. He also has Eddystone functionality in there. So if you have one of these Arduinos, you can include the Eddystone header, you can set a transmit power and a URL, and then you tell it to loop. And with less than 10 lines of code, you're creating an Eddystone beacon. So for that lamp over there, I use the physical beacon here, and I have my Bluetooth hardware there. If I'm actually creating a product, I'll probably want to have those combined into one piece. But they're conceptually two separate things, but you could have one set of hardware running that. If you're on a platform that runs Node.js and has Bluetooth support, I have a really small library called Eddystone Beacon, which in a couple lines of code lets you broadcast an Eddystone Beacon. One of the nice things about the spec being open is if you're on a platform and you're doing Bluetooth, as long as you have access to the advertising data, you can actually build an advertising packet that'll advertise Eddystone Beacons. So the spec is open, it's fairly straightforward. You have to advertise the Eddystone service, and then you are broadcasting characteristic data. You use the same UUID as the Eddystone service, and then this would be broadcasting abc.com. This is an old slide because it's an HTTP URL, not HTTPS. Technically, you can broadcast HTTP URLs, but any of the scanners are probably going to filter that out. One of the other things is, since this is just Bluetooth, if you have, works really well on Android, there's NRF Connect, which is a Bluetooth scanner. You can go out and scan, and it will actually find these Eddystone URLs, and it'll show you details about it and let you see. You'll see the raw URL, like the short Google URL, rather than the full Philly Emerging Tech URL. But you can definitely get in there and see what's happening. If you want to scan for beacons, a good place to start is the Eddystone Beacon Scanner, which is another library by Sandeep Mistry. And it's basically with a few lines of code, you create a couple callbacks. Whenever a beacon comes in, it gives you that beacon data. Plus, you get a chance to look at the source code to see how it works. So if you're on another platform and you want to do the same thing, you can write that. So I think the important thing here is that you can go out and build something. You don't have to have a huge infrastructure project to make this happen, although I think they're working on places to try to make cities smarter and do stuff. But you can create, like I said, you can create a web page for your dog and give them a beacon. You can create some lights in your house or something like that. Basically, any service, you throw a beacon on it and make it happen. Think about how you can really leverage the web and existing web stuff that's out there. Check out the physicalweb.org because they got a lot of great examples there, a lot more information, a lot of source code. And so you need a beacon, a device, and a web page, and you're ready to get started. So that's it for my slides. I got some time. I can answer some questions for you and go from there. Thank you. Yes. Wait for the mic, I guess.
So you gave an example of, say, parking meters, but how well would they work since they usually come together in large clusters, so you would detect like 20, 30 parking meters, and you would have to find which one you're actually talking to?
So yeah, the question was, how if you're in an area, there's going to be a bunch of parking meters around. How do you know which parking meter you're connecting to? So if you go back and you look at watch that video, you'll see the parking meter actually has a number on it. And when the notification comes up, the web page says, parking meter number 235 or something like that. So part of that is, as a user, I'm going to look to make sure that the parking meter in front of me is the one I'm connecting to, because I could connect to the wrong one. In that demo, once you connect, there's up and down arrows to add time to the meter. As the user adds time, they see the parking meter reacting too. So they're really relying on visual cues to know that you've connected to the right one. So now how do I actually make that show up in the list is when you're scanning for Bluetooth stuff, there's a RSSI, or relative signal strength indicator, which is a guess on how far away you are from an object. You use that with the transmit power. So ideally, the scanner is going to look at those and it's going to try to rank order them to see that, oh, this signal is much stronger than that one over there. And you can tune the hardware so that you know, hey, I want this to work really well when someone's within 5 feet of it, or whatever that range is. So hopefully they're designing the hardware well and the scanner's working, and that way the choices will be narrowed so you can pick the right one.
It would be like the Places API where you get a suggestion of the top 2 or 3 maybe, right? So you'd select maybe that might be how, here are the 3 meters near you, or?
Yeah, something like that. So I don't, since that's built into the Android Nearby API, I don't really know how that works, but yeah, there's some rank ordering algorithm that they're trying to do the right thing for you.
Is there any, as far as security measures, there password protection on the beacons, or could other people mess with them?
Yeah, so that's a good question. Is there password protection on the beacons? So the Eddystone, the Estomote beacons I'm using, when you take the Estomote beacons out of the box, I logged into the app and I claim a beacon. So then I own that. So the way beacons work is they're broadcast only as far as the beacon part goes, but to configure it, there's actually a Bluetooth service. So I connect with Bluetooth and I do stuff there. So the Estomote app makes sure, I'm not sure exactly what they do, but there's some token or something that's in there. So that way, if you get the Estomote app, you're not going to be able to set my beacons. Yeah, so other ones, like this one here has a 8-digit pin on the Radius Network ones. And I think you can set a pin on these, but if I turn some of these on in configuration mode, people can steal them. And these are really made for development, so it's not as important. But right, when you're putting stuff out there, you do have to worry about someone hijacking your beacon and setting it to their own thing, but also, physical theft of the beacon too. That way, this one's nice, you can really bolt it down to something. But if you just had one of these stick-on ones, I'd imagine they get stolen sometimes. I don't know.
What would, for the parking meter example, what would hold my credit card information? Because you're trying to make it simple, I should just be able to go up to a parking meter and hit pay, end of story.
Right. So for the parking meter, what would hold the payment information? You would be interacting with the website for our wonderful Philadelphia Parking Authority. If they could get their act together to run a website, you could do Apple Pay to the PPA website, and then the website would tell that particular meter that, hey, this happened. So one of the things that would happen there is that the meter actually has to be connected to the internet, which seems like, oh, hey, you got all these meters, but it's actually fairly easy to do for, if you're buying one of them, the particle that I had, they have a cellular-based one. And I think it's $70 if you buy one, and it's a couple dollars a month for a plan, so if you bought lots. So that device can be connecting to the server also, so it's going to believe the server that says you paid rather than believing my phone. But yes, you could do PayPal, you could do anything.
So from the server perspective, is there a way that I can know that the request that's coming in came from a phone that got there via the beacon, or could anyone anywhere connect and pay any parking meter?
Yeah, that's a good question. So it really wants to know from the server, are you actually in proximity of the beacon? Yeah, there was some things at CES, they did some beacon scavenger hunts. One year they did it with iBeacon, the next year they did it with Eddystone, and Aldershot Allen and Sandeep Mistry actually wrote some code to win the beacon when they were in Canada and the UK, so they weren't there at all. Yeah, so you definitely want to do that. I think part of it could be you could have something passed in the URL from the device. I don't know. There's nothing that comes to mind. There's definitely things you could do, but there's not like a standard recipe to say, oh yeah, you're definitely in front of this meter and paying for it. And that actually could be, like if you were able to renew a meter, that could be something good because they wouldn't want me in here adding money to my meter, so I'm not getting a parking ticket.
Because there's not really any like handshake between the beacon and the device.
No, I mean really the stuff that we were showing here is it's just the URLs going there. It's the same as me typing it in. Like if I didn't want to have Bluetooth enabled and there was a URL on the park meter or QR code, I could actually type that in.
Do you know if Apple has an official stance on building this into iOS?
I don't know. I know that Scott Jensen's a pretty persuasive guy and he knows a lot of people, so I'm sure he's lobbying for that. But I mean, who knows? It would be nice if it happens.
Is there a concept of having a phone or some app do something automatically in response to a beacon without going through sort of that notification flow where the user has to consciously accept it? Or is that something that's kind of just up to the app? It could, if you make your own Eddystone sort of receiver app, it could just do whatever you want.
Yeah, exactly. So the question is, like, can we make an app or something that happens automatically without any user interaction? So the way the physical web is set up and defined, the answer is no. If you're doing through the web, you really got to have that user interaction there. But there's nothing to stop you from writing your app that passively scans for these beacons and does something automatically in the background. And that's like when you see iBeacons that are built into a lot of apps. They're just broadcasting a garbage number, but when an app knows it's in the proximity of that, it actually does something. You can do the same thing with these apps. So you could, even if there was beacons that were somewhere that you didn't put in, but you wanted to use them in your app, you could do that because that data is just being broadcast out, and you could have that happen in the background. It's easier to do on Android because on Android, when you're scanning for Bluetooth in the background, it happens more responsively. You can have iOS scan for Bluetooth stuff in the background, but there may be a 5-minute delay on some of that stuff. So it has to work with your use case.
Can you change the URL dynamically on the beacons, or is that a one-time setup?
Yeah, so can we change the URL? On this hardware here, the way it's set up is I have to just set the URL and have it be fixed. If I'm creating beacons with an Arduino and using those libraries, I can change the beacon there. I can update the advertising information. One thing that these hardware can send out multiple beacons at once. It can interleave beacon packets, so you could actually have one piece of hardware send out, let's say 10 or 50 notifications, depending on how you time slice that. So if you were building your own hardware, it would be no problem to roll different URLs. Or there's one, I haven't actually built any that do that, but to append a parameter on there so you can actually pass data. So they talked about having like a temperature sensor that wasn't connected to the internet, but appended the current temperature onto the URL. So that way when you open the web page, you could actually know what the current temperature was there. All right, well, thank you guys very much. If you want to come up and see the beacons, come up, mess with the light. Thank you.